Okay, hello. In this video, I will explain how to configure or how to set up the memory interface. Uh, in the memory interface, we have a three kind of memory interface. The first one using memory, RAM, and ROM, and also FIFO. We have FIFO, VRAM, and also RAM. For the default one is using the AP memory in here in the default, but we can choose the protocol for input output data for accessing the which one we will store the data using a FIFO protocol or VRAM protocol. Okay. In this lab we have five. It's not the file. We have a file here. This is C header test, and this is the data for comparing the result. Let me explain for the for the C file. We have a array accumulation in here. We have a two array input here, di and do. Di for input, do is for output. In here, we accumulate the di data. Accumulate the di data in here, and the accumulation is between n number data. So di is array with n number data. The output also have the n number of data, and we will accumulate di and store it into do. For the first one, we have a temporary data in here, acc .ram, which RAM is same as the n data, and the I have e here. So we will accumulate the I with the first row until the final row. For the test bin file, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 5, 15, 16, 17, 18, 19, 20, 21, 5, 6, 7, 8, 9, 10. We have a 33 n data. 33 n data. So it accumulate from the first number, 10 accumulate by 20. So the first result in here is 10. The second one is 30. The third one is 30, 60. Some accumulation from the first row until the final row, and save it into the result DAT. And we will compare it result.dat with result golden DAT. Here we will compare the result of accumulation between two files. Now we will run the project in here. We will run the project in here using a TCL file. In the TCL file, we'll open project and open the project, make a new folder with array IO project, and add C file, add C test bin, and also the data for comparing. And we have a clock period in here for nanosecond, and only simulating using a simulation design here. I make it into, okay, let's let's run it. open the this ls and copy into cd here, and now run the tcl file feed this hls -f run akumulator.tcl file. Okay, the test is passed in here. Now we open the project with this hls-p. Open the project. The project name is array io underscore. Now after opening the project here, opening the project, we will run the C synthesize first using an active solution. And we can see here the report, synthesize report, array report. We have a clock latency 34 cycle, and the time latency only 0, 1, 36. And we have the device in here. The load is 89. We have not using a FIFO. We have a memory 65 and 4 load in here. Okay, we will change the input and the output memory from the AP memory to FIFO. We will change it, and we will see how is the result in here. How is the result in here? Okay, we make a new solution, number 2 solution. So the active solution is number 2, and we will change the C here, C here, directive. We will change the I and the O. The I using AP memory, the O using the FIFO. Insert directive. For output, this is bind storage using a FIFO, and the implementation using also the FIFO. Oh, sorry. Using a VRAM. It's not changed. Okay. Let me see again, check again. Insert directive DI using a FIFO. di is changed into the RAM and VRAM. Okay, di it's not di using RAM and here using VRAM. Okay, for do interface from the directive using the interface. Using the interface. The interface using the FIFO. AP FIFO. Okay. This is for changing the memory protocol, and we will change also the loop here, for loop here. For loop, we will change to make it unroll. To make it unroll. What is allocation and unroll? The allocation, they will maximize using memory, but with the lowest latency. So they will make it up into the parallel, and so we will using many memory here, but the latency is lowest. Let me see. Let us see how let we compare it, the first solution and the second solution. Now we will using unroll. Unroll means the for in here, for iteration in here will make it into series, not parallel device, but series, only one device. So process one by one iteration, and so we will have a less memory but with high latency in here. We make it unroll and press OK. Now run the C synthesize. Okay, the solution to synthesize report. Okay, we compare. Let we compare. Okay, let me compare. This is the solution one without unroll and all using the memory here. Using memory 64, and this is using AP memory protocol input and also output using AP memory protocol, and the latency is only 0.136 latency. But after we synthesize new device, we have many without any memory, because we make it into FIFO without any memory. And now all using the FIFO here, all output, but input still in the VRAM. How many VRAM we have? And the latency is lowest in here, 0.132, because using a FIFO, and latency will reduce 33. Clock clock, same clock, but using less memory because we are using the FIFO protocol. This one for FIFO. So I'll using a multiplexer to make it FIFO. But in here, using the memory, how many memory that we are use. But in the second solution, we use many multiplex here to using it with the FIFO to make it the FIFO communication. But in here, we are using memory. Here, we don't have memory. So this is how to change the I/O memory protocol for changing from the memory AP memory to AP protocol, FIFO protocol in here. See you in the next video.